Hi folks, and welcome to this video on mandatory conversion. When we speak of mandatory conversion, we're speaking about converting a convertible bond at the issuer's option. In this case, what we say is that since the issuer cannot be forced to pay cash, they can choose to do that at maturity, but they can choose not to do that and just issue shares. Because we know they can't be forced to pay cash, we assume that the bond will be convertible into common shares because this would be the least impactful in a negative way on their cash flow. So we use the incremental method to value the liability, and the equity is squeezed out as a residual. But now don't forget, because we make the assumption that the issuer will not pay out the face value at maturity, that means that the only liability we're going to present value is the interest payment itself. So that's why we say in this last bullet point here, the liability is valued at the present value of the interest payments only. And again, that's because we can't force the issuer to pay the face value back at maturity. So we assume shares will be issued. So let's look at an example. And in this example, it says ABC Company issues a $100,000 6% bond, and they get $103,500 for it. The bond is mandatorily convertible into common shares at maturity, and the bond pays interest annually. The term of the bond is 4 years, and the market rate is 8%. So now, to record the bond at the issue date, we have to do the first thing we have to do is to calculate the present value of the liability, and the liability here is not the entire bond, it's just the interest on the bond. So the first thing we're going to do is find our PMT, or our interest. So on a $100,000 bond at a 6% coupon, because the bond pays interest annually, we don't have to allocate or multiply that 6% by any fractional rate. So we just take the 6%, because that's an annual rate, multiply it by 100,000, and we get our payment of $6,000 a year. So now to present value that, we have a $6,000 PMT. We know that our market rate is 8%. The term of the bond is 4 years. And don't forget, our future value is 0 because we don't pay out at maturity the face value of the bond. So if we did a compute PV, we'd have $19,873. So using the incremental method to squeeze out the equity piece, we take the amount that we paid for the bond, less the value of the liability piece, and that gives us the value of the equity piece. So at issue date, we're going to debit cash, credit the interest liability on the bond for what we calculated in the present value, and credit the balance to the equity portion of the bond, which is going to be $83,627. And this interest liability is going to be amortized over the life of the bond so that we can book interest expense. So when we're doing our schedule to show interest expense, that would be booked by the company every year. We know our interest liability is $19,873, and you can see this little 4-year chart. By the time we get to the end of year 4, we don't have any more of a liability. So that means it's been fully expensed over the 4-year period. So how does that happen? Well, don't forget, the interest is calculated based on the carrying value of the liability at the beginning of the period, which is $19,873, times 8%. That gives us our interest expense. Our interest payment, we already know, it's set by contract at $6,000. So our ending liability for interest is going to be the difference between the amount by which our interest liability increased this year, and don't forget, this is interest expense. I should probably put that in. Interest expense during the year, but whenever we debit interest expense, we credit the interest liability, right? So this makes the interest liability go up, and this makes it go down. So at net, our liability is going down by the difference between these two, which is $44.10, right? So if we started off with $19,873 and our liability goes down by $44.10, which is the difference between the amount it goes up by, which is $15.90, and the amount it goes down by with the payment, which is $6,000, at net it goes down $44.10, so our ending liability is $15,463. We can see what the journal entry would look like now that we've got the chart. In fact, some students would say it might be easier just to have a look at the entry so we can better understand where this 4410 comes from. Well, don't forget, in year one, you're going to book a debit to your interest expense, which we calculate as the carrying value of the liability times the market rate, which is 8%. We already know our PMT is $6,000, so the difference between the expense debit and the cash credit is a debit or a reduction of the interest liability of $4,410. It's the difference between the amount of cash paid out and the amount of interest expense booked, because this interest expense also has the impact of increasing the interest liability, and the cash payment will reduce the liability. And the net effect on the liability is to reduce it by 4410. Hence your 4410 here, which gives you an ending balance of $15,463. If you don't like the entry this way, you might want to think about it this way, which is the way your textbook does it. They say, well, let's do this in two steps. Let's book the interest expense and credit the interest liability by $1,590, and then let's pay the liability down when we credit cash. But I've got these two parts here bolded because that is your 4410. That's your liability increasing and your liability decreasing. So at net, your liability goes down by, at net, 4410. So we've got our opening liability going down by 4410, which leaves us an ending liability of $15,463. And if we multiply that by 8%, we're going to get $1,237. So the difference between that interest expense, which also affects your interest liability, it goes up, and that payment, which makes your interest liability go down, right, is going to give us an ending balance in the liability of $10,700, because it has the impact here of decreasing your liability at net by $47.63, which is the difference between these two guys here, right? So the other way you can do it, if you don't want to do it as two entries, you can do it the way we've done here. You can debit the expense, $1,237, credit cash, $6,000, because that's your payment, and debit the liability, the interest liability, by the difference, which is $47.63. So when we reduce the liability by $47.63, we get an ending liability of $10,700. So in our third year, we are going to calculate our interest expense as the value to open the period of the liability, $10,700 times 8%, right? And compare that to the amount by which our liability is going down. And that means our liability is going down at net by $51.44, the difference between $6,000 and $856. That's the amount by which our liability goes down. So to see this a little more clearly, we can see it here. Don't forget, whenever you book interest expense, you increase your interest liability, and whenever you pay interest, right, make your payment, it's going to decrease your liability. So these two here at net do represent your decrease in the liability of $51.44. So that means you're going to have a liability now for interest that started the period at $10,700. We reduced it by $51.44, so now the ending balance is $55.56. Multiplying that opening balance for the liability of 8% by 8%, your market, you're going to get interest expense of $444. Your interest payment is fixed by contract. So now you can see that the bond liability is going down by the amount of the payment, net of the amount it went up by, which is $444, which means that net it's going down by $55.56. So we no longer have a liability. It's done. It's gone. So what would our entry be? Well, again, you can do them in two steps. Record your interest expense and credit interest liability, and then pay down the liability when you credit cash, right? Or you could do it again as one entry. Debit the expense for $444, which is what you calculated up here. Credit cash, and then debit your liability for the difference. Now, don't forget, at the end of year 4, you have nothing left in terms of liability, and because it's mandatory conversion, right, a mandatory conversion, we know that the issuer of the bond is going to force conversion into shares. So the last thing we would do at the end of year 4 is debit the common share equity that we set up at the issue date, which was right here, 83,627, and we'd credit our common shares to issue the shares. Okay? So that deals with mandatory conversion. We also have another example coming up, a fixed versus floating conversion rates when we have mandatory conversion. So we'll get to that video in a moment. So take a moment, just compose yourself, and we'll come back in a few minutes and begin this video. Welcome back. Now for this second video, we're going to compare one of the problems which deals with a fixed versus a floating conversion rate. And what does that mean? Don't forget, we've been dealing so far in our course with fixed conversion rates, where they would tell you how many shares you're going to get if the bonds are converted into shares, right? When it floats, you don't know how many shares you're going to get at the conversion date. You don't know. You only know that you're getting the market value of however many shares you're getting. So with a floating conversion price, we don't know how many shares we're getting. So if we look at our question, Mecca Energy issued a convertible bond at August the 1st, X9. It's a 10-year bond, 4% coupon, face value is $12 million. Pays interest semi-annually every July 31st and January 31st. And it says at maturity, each $1,000 bond is convertible into 120 shares. This is fixed. That's why I have the arrow coming down here, the blue arrow here, because I can see it's fixed. Because I know upon conversion how many common shares I can get. So for the investor, there's something positive here, because they can compare the price at which they bought the equity component, right? What they paid for the equity component. And if they decided to exercise the shares when the market value was appealing, they can make money. And they know they'd make money because they know exactly how many shares they're going to get, right? So on each share, they're going to make so much money, right? So here we've got a fixed conversion rate because we know exactly how many common shares we're going to get. Now, conversion is at Mecca's option, right? That's the issuer of the bond. Now, the company may choose to repay the bond in cash, but again, don't forget it's mandatory conversion. They can't be forced. So the bond was issued for $12.5 million and the market rate was 5%. So if we're going to record the initial issuance of the bond, the first thing we need to do is we need to calculate the bond's present value. But don't forget, because this is mandatory conversion, I'll just put it up here, that means that the issuer of the bond is the one who can force conversion. And we say that because you can't force them to pay cash, the accountant makes the assumption that they're going to issue the shares. So that's why we say it's mandatory conversion, because we assume that the bonds will be mandatorily converted into shares, right? Because it's at the issuer's option. So now we have to figure out what the present value of the bond is, but don't forget, we're only calculating the present value of the liability piece to be that of the interest, because that's the only thing that the issuer has to pay. The issuer doesn't have to pay the face value back. Don't forget, it's mandatory conversion. We can't force them to do that. So what we need to do is to compare the issue price of $12.5 million with the present value of the interest. So when we calculate the coupon, or PMT, we get $240,000. So to calculate the present value, we have $240,000 plus or minus PMT, and again we make it negative because it's an outflow to the issuer. The market rate is 5. Your N is 20 because there's 20 interest payments over the term of the bond, and again your future value is 0 because the issuer cannot be forced to pay back cash. So if we do a compute PV, we've got the present value of the interest-only piece of $3,741,398. So using the incremental method, we squeeze out the equity portion at $8,758,602. So now at the issue date, we're going to debit cash for $12.5 million. We're going to credit the interest liability on the bond for its present value. And we're also going to set up the equity portion at $8,758,602. Now, in requirement 2, this is different. Now we're assuming that the bond was convertible into common shares at the maturity date, and it's convertible into common shares based on the market value of the common shares at that time. Notice it doesn't say how many shares we're going to get at maturity. So this is an example of a floating conversion rate. Since we don't know how many shares we're going to get, it's going to depend on the market value of the shares. So there's really no upside to the investor in this case when there's a floating conversion rate, because they really don't know how much money they're going to make, how much more money they're going to make. In fact, we're going to prove to you that they're not going to make any more money, right? So let's have an example here to show you why we say there's no upside to the investor. We know they're going to get an unknown number of shares at a particular market value, which we won't know until the conversion date, which is at maturity. So there's no advantage for them to take the shares. So let's just do an example before we get to our little question here and do it, just to show you why we say they have no upside. So for example, let's say we had a $1,000 bond that's convertible into floating number of shares at market value at maturity. So let's say the market value at maturity is $8 a share. Well, if we have a $1,000 bond, right, if we divide it by $8 a share, that means we get 125 shares. Well, those 125 shares trading at $8 a share is worth $1,000, right? If the market value is $10 at maturity, then that $1,000 bond divided by $10 at maturity, the share value at maturity, means I'm going to get 100 shares. Well, those 100 shares are still only worth $10 a share, the market value, so my equity situation hasn't changed. I'm basically getting $1,000 back, am I not? In either case. So I have no upside, right? But I don't know how much I'm going to get back exactly until I know the market. Well, I don't know how many shares I'm going to get, I should say, until I know what the market price is at maturity. So the investor doesn't know. So there's really no upside to them because they're basically getting the $1,000 back, right? They're basically getting $1,000 back. So there's really no upside for them. The only reason they may take this deal is because they might see a value because the bond is paying good interest, and they might want to get that steady cash flow stream, right? So now in our particular case, because we don't know the number of shares that they're going to be getting, we don't value the equity piece at all. So when we issue this bond, if it's a floating conversion rate, notice in this journal entry at the issue date, we do not have any equity piece here. It's total debt. Total debt. Why? Because there's no equity piece. There's no value to the investor to get the equity piece. So what we do as the issuer, we're going to debit cash for the amount that we're getting. We're going to credit the bond payable for the face value, and that extra $500,000 that's paid in represents a premium on the bond payable. So if the bond is convertible using the market price of the shares in the conversion date, the bond is straight liability with no equity component, because the equity component is, we can't value it, because we don't know how many shares we're going to get at maturity. So there's really no value in the equity component for the investor, so the issuer doesn't value it. So this concludes our discussion on mandatory conversion. I hope you found it helpful.